6.3. Theorem 6.3 states that if in two triangles, corresponding angles are equal, that means the three pair of corresponding angles are equal, then their corresponding sides are in the same ratio, because all the three corresponding angles are equal and the three corresponding sides are in proportion, and therefore the triangles are similar. This criterion is referred to as the AAA angle criterion of similarity of two triangles. We did an activity today to check that when we construct two triangles having corresponding angles equal, their corresponding sides are in the same ratio. But here we are going to prove this using mathematical statements and arguments. This theorem can be proved by taking two triangles ABC and DEF such that the three pair of corresponding angles are equal. So it is given that triangle ABC and triangle DEF are two triangles and angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, as you can see in the diagram. We need to prove that AB upon DE, the ratio of corresponding sides AB upon DE, is equal to the ratio of AC upon DF, and that is equal to the ratio of BC upon EF. And so we can say that triangle ABC is similar to triangle DEF. So let's understand the proof. Cut DP is equal to AB. So we are going to cut D, and somewhere here we are going to put a point P such that DP is equal to AB and DQ is equal to AC. So we are going to put a point Q somewhere here such that DQ is equal to AC. So for that, I'm going to take this triangle over there, and since angle A and angle D are equal, it kind of overlaps the triangle. So we will plot a point P here and point Q here, okay, like this. And now we are going to join PQ. So now if you look at these two triangles here, we have AB equal to DP according to our construction. Also angle A is equal to angle D, which is given to us, and AC is equal to DQ according to our construction. And so triangle ABC is congruent to triangle DPQ according to SAS congruency criteria, side, angle, and side. And therefore we can say that angle B is equal to angle P. Since these two triangles are congruent, all corresponding angles are equal. And so angle B is equal to angle P. But it is given to us that angle B is equal to angle E. So angle B is equal to angle P, and angle B is also equal to angle E. And therefore from 1 and 2 we can say that angle P is equal to angle E. Angle P is equal to angle E. Now if you look in triangle DEF, the bigger triangle, we have PQ and EF as two lines, and DE could be the transversal. Then P and E are corresponding angles, and we have proved that they are equal here according to our result 3. So PQ and EF are two lines and DE is the transversal in triangle DEF. Also angle P is equal to angle E from result 3, and therefore we can say that PQ is parallel to EF. So PQ is parallel to EF. Because if a transversal intersects two lines such that a pair of corresponding angle is equal, and as you can see a pair of corresponding angles are equal, then the two lines are parallel to each other. You have learned this in grade 9. Now, since PQ is parallel to EF, okay, we can say that dP upon PE is equal to dQ upon QF. This is a theorem we have just studied, the BPT theorem. So according to theorem 6.1, if a line is drawn parallel to one side of a triangle, so a line PQ is parallel to one of the sides of the triangle EF, to intersect the other two sides in two distinct points, here P and Q, then the other two sides are divided in the same ratio. And therefore we get this, dP upon PE is equal to dQ upon QF. And now we will reciprocal it, so we get PE upon dP is equal to QF upon dQ. Adding 1 on both the sides give us PE upon dP plus 1 is equal to QF upon dQ plus 1. Now the LCM of the left hand side becomes dP and LCM of the right hand side becomes dQ. So we get PE plus dP upon dP is equal to QF plus dQ upon dQ. Now look at the numerators here. PE plus dP, so PE plus dP gives you DE, the whole line segment, and QF plus dQ, so QF plus dQ gives you the whole line segment here, DF. So we get DE upon dP is equal to DF upon dQ. In place of dP, can I write AB now? Now look at this. This is dP. Can I write dP as AB? Yes, we can. Because these two triangles, triangle DPQ is congruent to triangle ABC. Therefore, their lengths are exactly the same. So instead of dP, we put AB. And instead of dQ here, dQ, we are going to write AC. So we are going to replace dQ with AC. We get DE upon AB is equal to DF upon AC. DE upon AB is equal to DF upon AC. So the corresponding sides are in the same ratio. Or since ABC triangle is here in the first place, we can write AB upon DE. So we are just going to reciprocal this. We get AB upon DE is equal to AC upon DF. Now, by taking the triangle here, and as we had cut a line PQ, now cutting a line here, we can show that AB by DE, so AB by DE is equal to BC by EF. And by taking the triangle on that side, we can show that BC by EF is equal to AC by DF. Okay, so we are not going to repeat the whole processes again, but we can show this by following the same process again. And so we get that AB upon DE is equal to AC upon DF, and that is equal to BC upon EF. And hence we have shown that the three corresponding pair of sides are in the same ratio. Now in triangle ABC and DEF, now let's take the two triangles. It was already given that the angles, corresponding angles are equal. So angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That was given. And we have proved that the three pair of corresponding sides are in the same ratio. From 4, we can say that triangle ABC is similar to triangle DEF. Now we need to note that if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of triangle, their third angles will also be equal. If two corresponding pair of angles are equal, the third one automatically becomes equal. Therefore, this criteria, which is called AAA similarity criterion, can also be stated as follows. So for AAA similarity criteria, we consider 3 pair of corresponding angles. That could also be true for 2 pair of corresponding angles. Because if 2 pair of corresponding angles are equal, the third one is automatically going to be equal. So if 2 angles of one triangle are respectively equal to 2 angles of another triangle, respectively means the corresponding ones, then the 2 triangles are similar. So even if we can show that 2 pair of corresponding angles are equal, then also we can say that the triangles are similar. This may be referred to as the AA similarity criterion for 2 triangles.